Welcome to part 2 of our video series on section 1.3. We're doing word problems. This is probably going to be a pretty short part 2. There's only one more word problem that I want to talk about for this section, and it's the bus problem. I like this problem. The bus problem is bus fare is $1.50 for someone without a bus pass. It's only 75 cents for someone with a bus pass. I know that usually having a bus pass means that you just get to ride the bus for free, but in this particular story problem, it's not a free ride with the pass, it's just a discount. So, if the bus pass costs $21, how many rides make it worth it? For this problem, we need to think about what worth it means. Obviously, if you only ride the bus once, buying the bus pass is a terrible idea. That one bus ride with the bus pass will cost you $21.75. Without the bus pass, that one bus ride only costs you $1.50, so you shouldn't buy the bus pass. But presumably, if you ride the bus a whole bunch, these $1.50 fares will accumulate so much that this $21 pass, to make these things cheaper, will add up, and your total fare, like if you ride the bus 100 times, this is $150. This way it's $75 plus $21. It's $96 this way. So somewhere between one bus ride and 100 bus rides, getting the bus pass becomes the cheaper option overall. And that's what we're looking for. So again, kind of the general benchmark all-around strategy is the first thing you want to do is determine and label your variables. And if you're struggling to figure out what the variable should be, always look at the question statement. How many rides make it worth it? How many rides is the thing that you should be looking at to determine your variable? So I'm going to let x equal number of rides. If x is the total number of rides you're taking, then I want some variable p. This is the cost with the pass. Actually, I don't really need to even give this a name thing. I'm just going to say x is your number of rides. The cost with the pass is something that I need to figure out for x number of rides, and the cost without the pass is something I need to figure out for the number of rides as well. So cost without the pass, if you ride the bus x times and you don't have a pass, that costs 1.5x. $1.50 times x bus rides. This is your total cost. Cost with the pass is going to be 0.75x plus that $21 pass. Worth it in this case means we're looking for the point at which one of these values surpasses the other value. So we're basically looking for where they're equal. If we can find the number of rides that make them equal, then we can pretty safely assume that more rides than that and the bus pass is the better option. Less rides than that and not getting a bus pass is better. And if you were doing exactly that many rides, then it doesn't matter. They're the same cost. So let's find where these two things are equal. So just like the college problem we did in the last video, we're going to set them equal. So I'm going to get 0.75 plus 21 equals 1.50 x. I'm going to, x goes here as well. I'm going to subtract 0.75x from both sides because this is the point where I just have a linear equation and I just need to do some math at it. So I'm subtracting these and I'm left with 21 equals 0.75x. And now I just need to divide by 0.75. 21 divided by 3/4 is, I think, 28. Yeah, because we're multiplying by 4/3. So yeah. You need to ride the bus 28 times. All right, I should say, if you ride the bus exactly 28 times, then buying this bus pass doesn't matter. The cost will be the same with or without the bus pass. If you ride the bus less than 28 times, you should not buy the pass. You should just pay the full fare every time. If you ride the bus more than 28 times, then you should buy the pass. So that's how many rides make it worth it. 28. I should say 28 rides. So that's the problem. That's the basic idea of all of this is determine and label your variables and write that down. That's important. Students don't write this down a lot and then things go bad. Write down what your variables mean so that when you get to your answer, you can interpret it. Write down what your variables mean. Determine your relationships. Create an equation that you can solve. And then once you have solved your equation, interpret your solution with respect to the original problem. So make sure that your solution to the equation you created is actually answering the question that is being asked in the story problem. Those are it. Those are the steps. Good luck.